Welcome again. I'm so excited that you're here. We have been on this journey for 4 weeks. This is our fourth week, and our last week, it's crazy, right? So time goes by so quickly, and we've covered so much content, and we have so much to go, but we only have 2 more sessions left. Aww. Let's get right into it. For those of you who this is might be your first time, I'm like falling over my words, but I'm Miss Nelson, and I'm a math teacher, math coach, tutor. Any of those will fit. And I am with you today because we have been on a journey for the last 7 sessions. This is our 7th session together since February 2nd, preparing for whatever math exams you have coming up, clarifying some challenging areas in math or content pieces in math to help to give you some clarity and hopefully boost your understanding and your grades in the process. And I hope some of you have been taking notes of some of the exam prep tips along the way. So let's get into our time together, okay? So let's see. Here we go. Let me know, where are you tuning in from? Are you here in the US? If so, what state? Or if you're in the Bahamas, what island? I'm excited that you all are here. Welcome again. And we have a lot to cover. And so whatever we don't get to cover during our time together today, just know on Tuesday we'll just cover it there. But like I mentioned in previous sessions, when it comes to math, there's a lot to cover. So we've only been covering some heavy hitters, some things that really will make a difference in your exams, in your classes. And I'm excited to hear your stories. So if you have a story, or if you have an experience or a way in which you feel like this time together has been helpful to you, go ahead and email me or direct message me on Facebook, or you can leave a comment in the chat on YouTube and let me know, how has this been for you? What are some areas that you felt like, man, I finally got an understanding of something I didn't know before? Or you can send me a short testimonial or whatever via email at reteachlearningllc@gmail.com. Okay, so where are you tuning in from? And then here's my legal disclaimer before we get into our lesson today. I really wish I can swing some pendulum in front of your face and say, you will get an A, you will get an A. And it works, but it doesn't work that way. It doesn't. So everything I share with you is for educational purposes only. I'm not telling you what to do, but I'm giving you some tools to put into your little toolkit that will be useful and valuable and beneficial if you decide to use them. The exam prep tips I give at the end of our lesson, these are scientifically proven. You can go on YouTube, anywhere really, and just type in top exam prep tips or habits, and these things will pop up, because these are the things that successful people implement so that they can get or be at the top of their game. And so I want to see and hear your stories of how you use these things. And so, yeah, how is this time going to go? And for those of you where you've been seeing these videos for a while and you've been with me since the beginning, you already know. But for our new people, our new folks in the building, we have an opening exercise. And then we're going to go into some reteaching, some concepts that you have seen before or you probably never have seen before, but I'm hoping to give you a better foundation in your understanding concerning those concepts. And then there's going to be an exam prep tip, and lastly, some resources for you. I hope you all have been enjoying the worksheets I've been leaving on my website at reteachlearning.com. And so you can go there, go to the resource tab, and you'll be able to access some of the worksheets that go along with our sessions over the last few weeks. And so, yeah, let's get into our opening exercise, because there's a lot I need to go over, I want to go over, and I think you'll enjoy this. Maybe not as much as I will, but I think you will, okay? So what's our exercise? So we're going to do a little bit of a journaling activity. So I cannot see your journals, obviously. There's a camera in front of me, but you can. So you're going to answer 3 questions, and I'm going to give you an example of how I did this for myself so that you can have an idea of what you can do. Now, this activity is very helpful if you're about to graduate, or if you've already graduated and yeah, it hits home more so for those people because they're out of school or they're about to take the leap or the jump and they're not really sure what to do. For those of you who are taking BJCs, chances are you have a few more years left in school, and so the real world is a little further away than it is for those who are about to take the leap in this year. So, what is the activity? What are we going to do? Well, this is what we're going to do. 3 questions. You can write them down. You can take a screenshot and you can look at it a bit later if you want to. But here's the first question. I want you to think about what, now for some of you, this might be a little bit of a triggering exercise. Take a breath, okay? Calm down and let's just do it together. Listen to what I'm saying. Here we go. What does your life look like now? All right. You're going to write that question out and write down some elements or things about your life. What do I mean? Well, where do you live? How do you spend your days? Do you enjoy your day-to-day activities? Can it be better? If so, but it could be better, okay? What does your life look like now? What are your hobbies? What are the things you enjoy doing? Where are the places you enjoy going? Who are the people you enjoy being around? And I want you to write that down, okay? Now, some of you might need to just pause. If you really want to do this activity now, you might want to pause the video and then keep going. And then what's the second question? Well, the second question says, what do you want your life to look like? Now, this is in reference to what dreams do you have? Or maybe how can the things that you're living now, how do you want them to be different or maybe more enhanced in the future? Right? Some of you already have a great life. Oh my gosh, it's amazing, right? There's nothing I would change about my life. That's some of you guys. But the majority of us who live in the real world, that's not the case. There are some things about the life we live now that we're like, okay, this can be better 5 years from now, or this is the life that I'm looking at wanting to pursue or have. And then the third question is this: what steps will you take to get from where you are to where you want to be? All right, now I want you to think about those 3 questions. You can take time to look at it or think about it now, or you can make it a habit at the beginning of every week, every Sunday. Just look at those 3 questions and you can reinvent them. You can redo them over and over again. But I want to give you an example of what, if I were to do this exercise in your shoes, you're in high school, or some of you, you're homeschooled, and that's fine too. But here's an example of what I did when I implemented this process. When I was in high school, I was about to graduate, and as crazy as it sounds, I was a head girl of my school, and I still was not like 1,000% sure of what I wanted to do with my future. That might sound crazy in the sense that you feel like the most successful or the students that are doing really well, they must know where they want to go and what they want to do with their lives. But that's not always the case. They're also trying to figure it out, as I was trying to figure it out as well. But what I knew was this was what my life looked like, and it was not ideal, but this is what I wanted to do with certain things or in certain areas of my life. So for example, I wanted to be an engineer. That's the career I was pursuing when I initially went to college. So I wanted to be an engineer, but here I was in high school. Okay, well, I graduated, but I did not get to go off to school right away to study chemical engineering. So here I am in the Bahamas trying to figure it out, and this is where I want to be, an engineer. So then I need to figure out, okay, how do I bridge the gap from where I am to where I want to be? I want to be an engineering major in college, and I want to be an engineer one day, but how do I bridge the gap? Well, here's what I did. I knew that the first year I was not able to go off to school, and the school I went to at the time was called COB, College of the Bahamas. It's now UB, University of Bahamas. I said, okay, the campus I was at in Freeport did not offer a chemical engineering degree. However, I wasn't going to complain about it. Instead, what I did was I looked at the school I wanted to go to, I looked at their chemical engineering program, and I looked to see what classes would I need to take if I was actually at that school. And every college and university has this on their website. It's accessible, where you can see their catalog and see all the classes you'd have to take if you wanted to do a certain major. And so, I want you to see my face. So basically what I did was I said, okay, I would have to take Algebra 1 and Algebra 2 and trigonometry, and I would have to take pre-calculus, and I would have to take some type of biology class or chemistry class. I would have to take psychology or some type of health science. I would have to take a history class and so forth, and an English class where I'm writing research papers and all of that, right? So I knew that I would have to do all of those things at this college I wanted to go to pursue this degree I wanted to pursue. But here I was in the Bahamas, not at that school. So how do I bridge the gap? Well, what I did was I did classes at COB that could transfer towards my degree in the future. In other words, I didn't spend time in a graphic design class at COB because I was not pursuing graphic design in the future I wanted. I was pursuing engineering. So what does that mean? That means that I made intentional steps where I was so that I can get to where I wanted to be. So I did classes like trigonometry, pre-calculus. I did science classes and psychology classes that I knew, the majority of them anyway, would transfer over so that when I got to where I wanted to be, at least, I would at least have some type of progress made. And so that's an example of this activity when I was in your shoe, what I would have done. But that doesn't just apply to school. That applies to any area of your life. If you can see where you are and develop a vision of where you want to be, then ask yourself, how do I get from point A to point B? What are the stepping stones to get me there? Okay? I want you to start thinking like that. If you are an adult, like 40, 50, and that's not a thought process for you, well, here's the beginning of a new journey. This is a way to consider, how do I get from where I am to where I want to be? Like I said, some of you, you're still in, have a few more years ahead of you, so you're not really thinking about that type of future, but you can be thinking about, okay, what do I not like about life right now? How can it be better? And how do I get from A to B? And let me put this in here, legally. All right, how do I get there legally? Not illegally, okay? I'm not like promoting crazy stuff. All right, let's keep going. So that's our activity. You can do it once a week if you want to, right? And then check your progress. Okay, did I do this week or last week? Okay, good. All right, so I'm on my way there. So just it's an habit that you can start forming even now. And that's our activity. That's the end of it because we have a lot to cover. All right. So when we were together last, which was last week, I ended a little bit early, but here we go. We did not get to finish our conversation on parallel lines. We didn't even get to start it. So we're going to make sure we cover it here. But I wanted to correct a little mistake that was made our last session, and it was on this question here. So I'm going to go through this question one more time and then edit the mistake I made in the last video, okay? Now, this is a lesson for our students. If you, let's say you did an exam or a homework problem and you're all done and you have time, go back and check your answer. It doesn't hurt, right? Check your answer to see if it's right. And that is just one step that will help your progress to like skyrocket, especially if it's just little minor mistakes that you find yourself all constantly making. All right, so let's take a look at this question from start to finish, and then I'll show you where the error was and keep going, all right? Now, because I'm doing the question live with you, I'm prone to error. Like if I was doing, I'm prone to error. All right, let's go. So here it says the size of a triangle are x centimeters, 2x centimeters, and x plus 1 centimeters. And I also want to pay your attention to the instructions that say not drawn to scale. What you'll find is that's commonly on a lot of any type of figures or drawings they have in your exams. They often put this information there. And what does that mean? That means that I don't want you to just look at this and say, ooh, that looks like 10 centimeters. No, they don't want you to do that. They want you to come up with your answer in a way that you literally go through a process to get it, a process that's mathematically correct, not by guessing. Unless they say, oh, guess the answer to this problem, which they'll never do for the most part, but don't guess, okay? If you give an answer and you ask yourself, how did I get this answer? And the response is, I guessed it. Then that's an indicator that, honey, you probably need to go back and study it. You probably need to go back and just take a look and ask some questions, all right? Now, I've had students that have given really good answers by guessing, but I want you to be confident, all right? That's one thing that I'm really passionate about, is you being confident that your answer is correct. And it's not just correct because you guessed it, but it's correct because you went through the right procedure or process to get there. So let's keep going. The perimeter of a triangle is 49 centimeters. Form an equation to represent this information. All right, now when we talk about perimeter, perimeter is talking about the distance around an object, any object, it doesn't matter. If you live in a house, if we say the perimeter of the house, what we're asking you is how many steps, or what's the distance around the house? If you go from one corner all the way around until you get back to the same corner you started at, what's that distance that you took around that house? So similarly here with our triangle, if I were to find the perimeter will be, let's say I'm starting from point A. I'm going to go from point A all the way to point B. So from A to B. And I'm going to add that distance to the distance from B to C. And the distance from C back to A. So I'm going back to where I started, plus CA, all right? So let's see what they tell me about the distances. Well, it says that the distance from A to B is represented by the variable x. We don't know the number yet, but we will eventually. So it's represented by the variable x. BC is represented by the term 2x. And then from C to A is represented by the expression x plus 1. All right, good. So now that we're here, what they also said is that the perimeter is, and is in math is an indicator that we're dealing with equal sign or an equivalent set of expressions. So equals 49. All right, so this is what we have. And we did this correctly in our last video. But we're going to go ahead and combine like terms to simplify our expression a bit. And what I notice is that I have an x, a 2x, and another x. So, and they're all separated by the operation addition. So I have to add them all. So I have 4 x's. So 4x plus 1 is equal to 49. Awesome. So now let's keep going. It says, number 2, solve your equation to find the value of x. All right, so let's go ahead and solve this. Now I'm going to go through this quickly because we have videos, number of videos talking about solving equations. All right, so the first thing we're going to go ahead and do once we simplify, we need to get the x by itself. So we're going to subtract the 1 on both sides. And we have 4x is equal to 48. And the last thing is to divide both sides by 4. Okay, and here is where I made the mistake in our last video. X is equal to, so 48 divided by 4. In our last video, I believe I put 14. It should be 12. So here we go. So this is where we make our adjustment. All right, so 48 divided by 4. That's right. All right, now, so x is 12. I'm going to put that there. And then the last one says, state the length of each side. So now that I know that x is actually 12, AB is represented by the variable x. And so it means that this is going to be 12 units, or 12 centimeters. BC is represented by 2x, which is the same as 2 times x, so 2 times 12, which is going to be 24 centimeters. And then finally, the last one is AC, and it's represented by x plus 1. So that's the same as 12 plus 1, which is 13 centimeters. Okay, I think you want to make sure that you have the units. In other words, if it says centimeters, put centimeters in your answer. If it says degrees, put degrees in your answer, and so forth. But that was the correction I wanted to make, and that is how you would do a question that looks like this. And for the most part, a lot of our questions going forward in the BJC, once they pass the questions regarding addition, subtraction, multiplication, division, and then they start talking about equations, what you'll notice is that a lot of the other questions following, although they may talk about other topics, they're going to involve equations, whether you're doing hire purchase, or discounts and markups and so forth. You're going to have to deal with equations at some point. So if you can get really good at writing equations from word problems, at solving equations, then you'll be good. Not like 100%, but you're at least going in the right direction. All right, so let's get into parallel lines because it will take us a minute. All right, so parallel lines. All right, let's take a look. Okay, so parallel lines are two lines, two or more lines. It really doesn't matter how many, but they are lines that are always equal distant apart. They never cross one another. So what do I mean? I mean that if you took a ruler and you measured, I'm going to use a green, you measure the distance from here to here, and you take that same ruler and measure the distance from here to here, so from both blue lines, no matter where you put that ruler, the distance will always be the same. It will never change if they are parallel lines. If you took that same ruler and you moved it across those two lines and the distance between them are changing, then those lines are not parallel, even though they look as if they are. They're not parallel. They'll meet at some point, maybe not on your paper because your paper is only so big. But in this case, they are parallel if they never meet or if the distance between them is always the same. All right? Now, here are some ways you can know if two lines are parallel based on looking at them. Oftentimes, we end up putting these symbols on these lines. It could be double arrows, single arrows, 3 arrows a piece, but usually if you see double arrows on a set of lines, usually they're saying that they are parallel, all right, double arrows. Now, if you're not sure, raise your hand and ask your teacher. That does not kill anybody or hurt anybody to do so, all right? Now, why are parallel lines important? Well, when parallel lines are crossed by another line, then we see different angles are being formed, all right? So we have angles formed all over the place, all right? All over the place. Now, the line that cuts a parallel line is called a transversal. A transversal, all right? So, take that in for a second. Parallel lines, lines that never cross. When those two lines or two or more lines, those parallel lines are cut, there are angles that are formed, and the line that cuts our parallel lines is called a transversal, all right? Now, why is that important? Like, why do we care about the names and the this and the that? Well, here's why. When we name these different angles, so the angles that are formed here, whenever we name these angles, we use the parallel lines and the transversals to describe the position of those angles. And if you can describe the position of those angles, that's going to give you an idea of the name of the angle itself. All right, so what do I mean? Okay, let's see. If you have an angle, and I'm just going to say this for now and you'll see how it applies as we go forward. If you have an angle that's formed on the outside of the parallel lines, then they will have the word exterior in their name, all right? If you have a set of angles that are formed on the outside of the parallel lines, when you name those angles, the word exterior will be in its name, all right? What does that also mean? Well, that also means that if I am dealing with angles that are between the two parallel lines, then the names of those angles will have the word interior in their name. Okay, I'm going to say it one more time. If you're dealing with angles that are in between the parallel lines, then the name of those angles will have the word exterior in their names, all right? So we name angles based on the parallel lines, where they are, whether they're on the inside or the outside of the parallel lines, but we also name the angles based on the transversal, all right? So let's take a look at the transversal for a second. The transversal, remember, is that line that cuts our parallel lines, all right? So I tried to do a little example. I hope this kind of makes sense. But notice that I have, let's take a look at the top one. Notice I have a little red arc, a semicircle, on opposite sides of the transversal. The transversal is that red line. So if the angles are on opposite sides of the transversal, then those angles, when you name them, they will have the name or the word alternate in their name. All right. Once again, if you're comparing two angles and they are on opposite sides of the transversal, then they're going to have the word alternate in their names. Okay? Now we're going to put all this into practice. So let's keep going. Now, the reverse is also true. If you're dealing with two angles that are on the same side, so for example, notice I have the two black semicircles or arcs on the same side of the transversal. Well, those angles, when I compare them, because they're on the same side of the transversal, they're going to have the word consecutive in their name, all right? Once again, if I'm comparing two angles that are on the same side of the transversal, they're going to have the word consecutive in their name, all right? You can take a screenshot. You can play that piece over and over again as much as you need to. But let's take a look at why that's going to be important, all right? If I take a look at this is a set of parallel lines, and they're being cut by a transversal. And what we're going to do is we're going to name these angles based on the information I just gave you, on the position of the angle, all right? Now, some of you have learned this in different ways, and it's okay to do that, all right? So for example, some of you have learned these different angles based on shapes, whether you see a C or a Z or whatever. If that works for you, power to you. You know, it's good. But I want you to understand that you can name them other ways as well, all right? Just by understanding the position. And the position helps because if you are asked the question, name a pair of alternate interior angles, you're not going to be confused about whether that's the C or the Z. You just need to figure out, okay, what does alternate means? Alternate means they're on opposite sides of transversal. Interior means they're in between the parallel lines. So if you're able to identify angles based on their position and name them in that way, then that's going to be beneficial, don't you think? I think so. All right, so let's take a look. It says, number one, name the pairs of angles indicated below using the diagram. All right, so they want us to name a pair of alternate interior angles. Alternate interior angles. So let's take a look at the interior part for a second. When we say interior, that means that we're dealing with the angles in between our two parallel lines. Okay? And then they said alternate. So alternate means they has to be on opposite sides of the transversal. So that means that C and X, they're on opposite sides of the transversal and they're in between our parallel lines. So that's a set of alternate interior angles. All right, so C and, I'm going to put a plus sign because I'm dealing with a lot of letters. C and X. All right, another pair is D and W. How do I know? Because they're between our parallel lines and on opposite sides of the transversal. All right, good. So, and then we have D and W. All right, now remember, we're naming them based on their position, and that's it. So, now that we're done with those two, let's take a look at another set. Let me move the colors for a moment. All right. Alternate exterior angles. So it's alternate and it's exterior. So I'm going to consider the exterior first because that means that they have to be on the outside of our parallel lines. So I'm dealing with AB and YZ. So it has to be out of those options because they're the only ones that are on the outside, on the exterior of our parallel lines. And then it says alternate. So they have to be on opposite sides of the transversal. So A and Z are on opposite sides and they are also exterior. So A and Z, A plus Z. And then the other pair is going to be B and Y. All right. So B and Y, B plus Y. All right. Okay, now I hope that's clear for you guys. All right, so let's keep going. Now, the next one they want us to name is a pair of consecutive, and another name that you might see is same side, because it means the same thing, consecutive interior angles. Consecutive interior. So we're dealing with the inside, interior. So inside our parallel lines again. All right, so interior. Excuse me, I'm sorry. And then they have to be on the same side, so consecutive. So W and C are on the same side, and they're inside. So they're consecutive interior angles. So we have C and W, C plus W. And then the other set is X and D. All right, X and D. All right, and then lastly, at least for this slide, they want us to do consecutive exterior angles. So exterior means we're dealing with the angles on the outside of our parallel lines, and they're consecutive, so we have to be on the same side of the transversal. So Y and A are a pair of consecutive exterior angles, so Y plus A. And lastly, what's the next pair, guys? B and Z are consecutive exterior angles, so B plus Z. All right, so now that we did that, is there any other information we didn't know about these types of angles? Yeah, there is some more information you might need to know. One is that the alternate angles, the alternate interior and the alternate exterior angles, these angles are all congruent. Congruent. That means that they're equal to one another, okay? And then for the consecutive angles, these angles, all the ones that are consecutive for this example, the consecutive exterior and the consecutive interior angles, these angles are what we say supplementary. I won't be able to spell the whole word, but they're supplementary, which just means that they add to 180 degrees, all right? 180 degrees, they equal 180 degrees, all right? So you can go back through that as much times as you need to, and we're going to keep going, all right? Now, was that all of the angles? Well, let's take a look. Can you name these angles? The other two, then, this is the last set that we did not talk about in our last slide. What about these two angles here? How would you name them? Earlier we mentioned that we name these angles based on their position, whether they're on the opposite sides of the transversals or inside or outside the parallel lines. Well, if I were to describe the position of these angles, they're on the same side of the parallel of the transversal. So, okay, can I use the word consecutive? Maybe. They're on the same side. But are they on the outside of the parallel lines? No, one is, but the other's not. Are they on the inside? No, they're not. So how do we name this particular set of angles? Well, the way we name this one is different than the other ones. And this is the exception, okay, to the rule. The exception to the rule. So here we go. These angles are called corresponding angles. And corresponding angles, these are angles in the same relative position, all right? And these angles are congruent. What do I mean by the same relative position? Well, earlier we said that we're going to name these angles based on their position in relation to the parallel line and the transversal. Well, let's describe the position of these two angles. If I were to describe their position, they are both to the left side of my parallel line. I don't know if the screen is flipped for you, but they are both on the same side of our parallel lines. In this case, the way I'm looking at it, it's to my left. And they are both below their respective parallel lines. So I'm literally using the same description to talk about the position of these two angles. They're both on the left of the transversal and below their parallel lines. If you can describe a pair of angles where they're literally on the same side of the transversal and on the same side of the parallel lines, then that's an indicator that we're dealing with corresponding angles, and corresponding angles are congruent. All right, so why is that important? Well, here's an example of a question I came across on one of our BGCSE papers about parallel lines, and we're going to use this information to help us out, okay? So here we go. If you're having a hard time seeing the screen, go ahead and, if you're on a phone, go ahead and pinch that thing in a little bit. If you're on a computer, you should be able to zoom in as well to see a little bit closer. So let's see. So it says not drawn to scale. Again, you're not going to guess this answer. You're absolutely not going to guess this answer, okay? But let's see if we can figure it out. So it says calculate the size of angle X. Now, keep in mind that this question or this section came from our previous session together. So I'm piecing together some of the things we learned in our last session, and we're bringing it all in to this question here. All right, so I need to find the value of angle X. All right, now in our previous session, we mentioned that, if I want to find the value, and mind you, there's multiple ways to do this, but if I want to find the value of angle X, what I would notice first is this. I have a straight line angle formed between angle X and the 126-degree angle. That's a straight angle. So we know the measurement of a straight line is 180 degrees. But what they've told me is that a portion of that is 126. So what does the other portion, represented by the X, have to be so that this entire angle, the straight angle, is 180? So in other words, if I have to get to 180 and I've already accounted for 126 degrees, how much is going to be left? Well, what I would do in this case is I would say, okay, well, X plus 126 is equal to 180. And then you can say to yourself, oh, okay, well, I can solve that. Let's subtract 126 from both sides. Okay, so let's go ahead and do that. 180 minus 126. And that's going to give us 64. So X is equal to 54 degrees. All right. Now, was there another way to do that? Absolutely. Absolutely. But this is the way we chose, and that's the way we did it. All right, next one. So that's angle X. Now we need to figure out what angle Y is. So I'm going to go ahead and just put the answer in there for angle X. It is 54. We need to know what angle Y is. So angle Y is right here. All right, good. Now, if I want to figure out angle Y, I can take a look at the parallel lines that I'm dealing with, because I do have parallel lines. So let's take a look at that. We have a parallel line here, and we have a parallel line here. And the line that helps us to form angle Y is cutting or is touching two parallel lines. And so we do have different angles that are formed when parallel lines are cut by a transversal. All right, so let's look at angle Y and see if we can compare it to any other angle. Well, angle Y is on the same side of our blue transversal as angle 126, and they're both between the parallel lines. So angle Y can be considered consecutive because it's on the same side of the transversal, and interior because they're between the parallel lines with the 126-degree angle. So that's one way to look at it. So that would mean that if they're consecutive interior angles, that they add up to 180 degrees. That's one way to look at it. For some of you, that's like, what are you talking about, Ms. Nelson? And then for some of you, you're like, oh, I got it. Yeah. All right, so let's do it that way, and then we'll consider the other way. So for angle Y, so Y plus 126 is equal to 180. And I can just solve this equation by subtracting 126 from both sides. And I get Y is equal to 54 degrees. And some of you would note, ooh, that's the same answer as angle X. And you would be right. It would be the same. Why? Why would it be the same? Well, if you also consider the relationship between angle X and angle Y, so let's look at angle X and angle Y for a second. They're both in between their parallel lines, so that's interior, and they're on opposite sides of the transversal, so they're alternate. So if I were to put those words together, some of you might say alternate interior angles, and alternate interior angles are congruent, or they're equal to each other. So we could have also done it that way as well, or any other way you decided. All right, so angle Y is 54 degrees. And then the last one is they want us to figure out what angle Z is, angle Z. Now, if you take a look at angle Z, and some of my students sometime will be like, ooh, that's a lot of work. Honey, you're right. It's a lot of work, but it pays off, okay? It pays off. All right, so if we take a look at angle Z is within a triangle. All right, it's within a triangle. And in our previous session, we mentioned that if I have angles in a triangle, if I know two of them, I can solve for the third one because the sum of angles in a triangle should be 180 degrees. So what does that mean? That means that angle X, which is 54, plus the 58 degrees, plus angle Z should give me 180 degrees. All right. Is there another way of writing it out? Absolutely. But what I'm going to do is I'm going to combine my like terms and just solve for Z. So 54 plus 58 is 112. 112 plus Z is 180. And lastly, I'm going to subtract 112 from both sides. So Z is equal to 68 degrees. All right. So these are our three answers for a question like this, dealing with parallel lines. Our time went by so quickly. Oh my gosh. All right. So I only have this one question, but what I would say to you is go on past, BJC or BGCSE papers and try this. Try naming the angles and figuring out, okay, how do I solve for them? And the more you practice, the better you're going to get. I'm sure of it, okay? And if you're not sure, come back to the video, write a comment in the section or whatever, or reach out to me via email, okay? And we'll see where we can go from there. All right, so what did I want to cover in our time together? Well, I wanted to get into some statistics, and more than likely we're going to continue this on Tuesday and finish up. But we want to talk about the mean, median, and mode. This is a question that commonly comes on all of these exams, and then get into some charts and Venn diagrams, okay? And that's the last bit that we're going to cover. So let's get into mean, median, and mode during our few minutes left, okay? All right, mean, median, and mode. So we're going to start with definitions and actually applying them at the same time so we can get through it. All right, so if you all need a break, take a break. All right, I don't need you falling asleep on me. Stay awake, I just sit up just now, all right? But yeah, if you need to sit up, sit up. If you need to stand up, stand up. If you need to do a few jumping jacks, do a few jumping jacks, okay? All right, so here we go. First of all, the mode. Now, a lot of the questions that I see asked on the exam, I had a student one time, and the question was asked, what does the word, they asked me, what does the word model mean? I don't know what they're asking me. They asked me to find the model number. What is that? Or modal number. And one of the challenges that some students may have, you may have this challenge, is that we go to class and we're taught in one language or using one set of vocabulary words, and then we go to the exam and we're using words only found in the encyclopedia. So, or words that they haven't heard before. So here's me telling you, whenever they ask you to find the model number or modal number, modal and mode, they're the same thing, okay? They're asking you to find the exact same thing. Now, what you can do, just to be sure, whenever your teacher asks a question and there's a word that's unfamiliar, you have been, well, some of you don't, but most of you should have two hands. So just go ahead and raise it up and ask your teacher, hey, I just want to make sure that this question is asking what I think it's asking, and or this word means what I think it means. And just ask the question just for clarity, okay? All right, so here we go. When I ask for the mode or the model or modal, however you want to pronounce it, doesn't matter to me. They want to know what number appears the most in a set of data, all right? So they'll give you some numbers or shoe sizes or whatever, and they want to find what is the number that appears most. So if we were to ask that question here, can you find the model number? Let's look for the number that occurs most times. I would say, okay, the number 12 occurs most times. So our mode in this question is 12, all right? Okay, so let's keep going. Median, how do I find the median? Well, what I want you to think about when you think about median is, and I don't know how it looks in every island, but whenever you're traveling on the road, you're traveling to school or something like that, there's a separation between the people driving on the right-hand side and the people driving on the left-hand side. That separation between the roads is called the median. It's what's going to separate you guys, all right? And another part of, or another thing to consider is that is in the middle of the road. It's between the two roads. So when we're talking about the median, we're talking about the middle number specifically. Now, what is the caveat, or what's the twist here? The data has to be rewritten in order, okay? It has to go from least to greatest or whatever, but it has to be in order before you look for the median. So let's take a look. It says the middle number after data is written in ascending order. So let's rewrite this data. So we have 5, 5, 10, 12, 12, 12, 13, 14, and 16. All right. So now that it's in order, what's the middle number? Now, sometimes when there's a lot of data, what I do is I do like a check between each side until I get to the middle number. And here we go. The middle number is 12. So the median is 12. All right, there we go. Now, last and finally, they want to know what the mean or the average is. The mean or the average. So the mean or average, they're asking the same thing, but it says the sum of all the values divided by the total number of values in the set of data. The sum of all the values, sum, remember, is an indicator of the operation of addition. So the sum of all the values divided by the total number of values in the set of data. So what do I mean? Well, first of all, we need to add all these things up here first, and then we're going to divide it by the number in total. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces, 9 sets of data. And at the top, let's go ahead and add them together. All right, now if you want, you can write out the numbers being added. It's up to you. 5 plus 13 plus 12 plus 16 plus another 12 plus 14 plus another 12 plus 5 plus 10. That gives me 99. Now, if you calculate it and your answer was different, then it is what it is. All right. And then 99 divided by 9, that's going to give me 11. All right. So my mean or average is 11. Now, notice that the average or mean is not actually a number in my data. And what does that mean? Why did I say that? Well, it can be a number in your data, but it doesn't have to be, right? Some people will be like, oh, I got 3, but that's not in my end. It's not a part of the data, and it's okay. It doesn't have to be a part of the data, but that's how I would find the mean, the median, and the mode. All right. All right, let's keep going. Here's a question. I have a few questions where they ask you about the mean, median, and mode. And I want you to see how they would ask these type of questions on exams like the BJC or the BGCSE. And have an opportunity to practice it, all right? So what I also want to make sure you're aware of, if you want to know where am I getting these questions from, how do I know if these are exactly the same, on the bottom right hand side of my slides, if I have a problem up, I'm going to put where that question is adapted from. And when I use the word adapted, it's because it's not the exact same question. It's just an adaptation of the question. And so you can go back and actually do the actual question on your own, just using the same steps and processes I used, all right? So here we go. The weight of 5 crates is, and they gave the weight of the crates, all right? State the modal weight of the crates. Once again, modal, mode, same thing, all right? So let's go ahead. Let's find the modal or model weight. So 1, 2, 3, 4. I think I'm missing one of the crates. So let's say we did 350 again. All right. So in this case, 1, 2, 3, 4. Yep. So now I have 5 crates. I missed one. So if we were to look at the modal number, it would be the one that occurs the most times. In this case, it would be 350. The modal weight, the model weight. All right, now the next one, it says determine the median weight. So remember, for the median, we need to line these things up, the weights up in order first, and then determine what the median or the middle number is. So let's go ahead and do that. So we have 340, 345, 350, another 350, and then the 355. Now, what I will say is this, how I'm writing this right beneath the question, you would want to do this on the scrap or the working section, not under the question, just in case they think it's your answer. But the median, the middle is going to be the 350 that's sitting right here. All right, there you go. Now, the question is, what if I have two numbers in the middle there? Well, if you have two numbers, then what you'll do is you'll add those two numbers up and divide it by 2. All right, you would add them those two numbers up and divide it by 2 if you end up having two numbers for your median. All right, let's keep going. Calculate the mean weight of the crates. So remember, the mean is I'm going to take the total and divide it by the number of data pieces that I'm adding together. So we have 340 plus 345 plus 350 plus 350 plus 355. And that's going to be divided by 5 because we have 5 pieces of data. All right. So let's go ahead and do that. 340 plus 345 plus 350 plus 350 plus 355. That's going to give you 1740 divided by 5. And that's 348 grams. All right. There you go. Now, why did I use grams? Well, because the other pieces or the weights were in grams. So you can use whatever unit that they used in the question in your answer. All right, let's take a look at another example. Jerry buys 10 jars of nuts. He finds that each jar contains the following amount of nuts. Okay, cool, awesome. Determine the modal number of nuts. Again, another question just like the one before, finding the mode, the one that is occurring the most. Looking at this, the number of nuts that is occurring the most is 54. 1, 2, 3. So 54 occurs most. So that's going to be our mode, 54. The median number of nuts, we're going to write them out in order. So we have 49, 50. 52 is twice. Yep. 50 occurs 2 times. 54 occurs 3 times. 1, 2, 3. And then 56 occurs twice. All right, so what's the median? Let's go ahead and do it. 1, 2. All right, so here we go. We have a situation where we have 2 numbers in the middle. So what are we going to do? Well, we're going to take those 2 numbers, add them, and then divide it by 2. So we have 52 plus 54. Divide that answer by 2. And that's how I would find the median if I have 2 numbers in the middle, which is what I said earlier as well. 54 divided by 2, that's going to be 53. All right, so this is our median. And then lastly, it says calculate the mean number of nuts. Once again, we're going to add everything together and then divide it by 10 since we have 10 data pieces. All right, so we have 49 plus 50 plus 50 plus 52 plus 52 plus 54. All right, so we got 527 divided by 10. And that's going to be 52.7. All right, now if you add them up and you got a different answer, it's okay. Just do the same process, okay, and you should be good. Now, here's another example, and I want you to take a screenshot of this one and try this one on your own. All right, this is your muscle work. All right, take a screenshot, try it, and when we meet again on Tuesday, I'm going to pick up here, all right? Okay, so now that we talked about mean, median, and mode, let's talk a little bit about some charts. What are some charts, examples of charts that you're going to see on your exam? Now, there's a lot of charts on your exam. Let's be very clear about that. But one of the reasons why I want to talk about charts a little bit is because, well, they take a lot of points. And we'll only get a chance to do one chart today, but we'll pick up and do some more charts when we meet again. So here we go. It says Anthony is a farmer with 100 acres of land. The graph below shows information concerning the crops he plants. Okay, so here's how I'm going to read this. First of all, notice that on the bottom, our horizontal axis or below our chart here, our bar chart, we have crops, right? So I should expect that these are different kinds of crops that he's growing in his farm or on his farm, all right? That's the first thing it tells me. Then it also tells me the number of acres. So it told me in the question that he has a total of 100 acres. So if I were to read this, it's telling me that for beets, because it's going up to the number 10, that means that I have 10 acres of beets, all right? 10 acres of beets. Another thing that I can gather from this graph is that if I'm looking at carrots, carrots stop at 20. So that means I have 20 acres of carrots, all right? So that's how I would read a graph like this. On the left-hand side, I'm looking at how many acres of this thing that we're dealing with. And on the bottom, I'm looking at what's the thing we're dealing with that's on that many acres. So how does that help me to answer the question? Well, it says how many acres are used to plant corn? All right, so I go to the corn and I look at how high this bar is, and I want to look at the number represented on this level. All right, so the number is 40. So that means that he has 40 acres of corn. All right, let's keep going. Which crop used the least number of acres? The least number. So what does that mean? Well, that means that I need to be looking at the bar that has the smallest height or the shortest height. And the shortest bar is here. It's the beets, and it's represented by 10 acres. So beets have the least. Beets. Now notice the question didn't ask me how much. It just asked what's the item, what's the crop that has the least. So I just answer exactly what they asked me to. I don't have to add any more, all right? And then the last part, it says how many more acres of corn were planted than potato, all right? So we're comparing two different crops. So corn, if we're looking at the corns are here. And there was 40 acres of corn, so 40 corn. And then if I'm looking at the potatoes are in red here, and there were 25 acres of corn. So 25, I said corn, potatoes. All right, so how many more? That's an indicator that we're going to be subtracting. So 40 minus 25 is 15. So 40 minus 25 is 15 acres. All right, so that's how you would answer a question like this or interpret a graph like this, okay? Now this question, like I said, if you want to know where it came from or, you know, where to look to have a practice question like this one, you can look at the bottom right-hand side of the screen, all right? Now, with that being said, I'm going to jump to our little exam tip today. And let's start by reviewing what we've already went over. First, we said we're going to break up our study time into shorter increments. You can, if you're doing an hour, you can just say, okay, I'm going to go ahead and do 30 minutes and then another 30 minutes. In between those 30 minutes, unless you really need to, you don't have to take a nap. Our brain doesn't need that much time to recuperate, honestly, once you're going to go study. If you're going to study, you can take like 5 to 10 minutes. And in those 5 and 10 minutes, do something that actually helps, okay? What might not help is to go and watch a movie because now you're introducing more information to the brain and it's not actually taking a break. So if you're going to take a 10 or 5-minute break, then what you need to do is do something that actually energizes or it gets your mind kind of clear and kind of ready to go again. So what does that look like? You might just need to take a walk. You might just need to just sit back and just breathe a little bit. You might need to do some exercises, something like that. But you don't have to go and watch a movie, because what that's going to do is literally just introduce more information into your brain that makes it a little bit more challenging. But who knows? Everyone's different. Everyone's different. Number 2, we said set study goals. If you're going to study, if you're going to do anything in life, you need to set a goal for it, all right? And then what's next? Take clear and ample notes, right? So make sure you're taking notes. And we talked about how to take good notes in math during that session number 3. The next one, it says create a study area. Have a space in your home or in your life where you go and study. If that's the library, the local library, go to the local library. If it's your school library, go to your school library. If it's a teacher's classroom at a certain time, go to the teacher's classroom at that time. If it's a dinner table at a certain time, make that your study area, and make sure it's quiet and it's it looks like, or it's an environment where you can actually focus in. And then it says use flashcards. Flashcards help, especially when we're talking about vocabularies or just remembering little facts. And the good thing about flashcards is you can take them wherever you go, put them in your back pocket, and try to recall different pieces throughout the day. And then lastly, one of the other areas we talked about was, let's get back there. All right, was practice using past tests or exams, okay? So go online, type in past and whatever exam you want to do, or practice SATs, or practice BJCs, or practice BGCSEs, or practice whatever exam. Go and look at those exams, those questions, and become familiar with it as much as possible. And so the exam tip that we have for today is this: ask questions. Ask questions. If I would, for me, this was like number 1. Well, number 2, I have number 1 tomorrow, but this is very high on my list, asking questions. Now, when I was younger, I felt some type of way about asking questions because I didn't want anyone to laugh at me. I didn't want anyone to know that I didn't know what I was doing. But let me be very clear. If you knew what you were doing, you would be the teacher, okay? If you knew 100% everything, you would be the teacher. And let me be very clear, as a teacher, I don't know 100% everything. So it shouldn't matter. It does to you, but it really doesn't matter if you don't know. If you don't know, just ask the question. Now, here are some creative ways to ask questions if you're embarrassed to put your hand up, okay? So, 1, put your hand up anyway. But if that doesn't work for you, another way you can do it is you can write a note to your teacher and say, Mrs. So-and-so, I don't understand this. Or it says you can send an email, all right? Just send an email to your teacher and say, hey, Mrs. So-and-so, Mr. So-and-so, I just want to know if this is right, or can you send me a video from YouTube to help me with this particular question? Or one of the things that I would often do is go to your teacher during breaks or lunchtime or whatever it is. Now, for the most part, teachers are kind of taking a break, but for the most part, hey, it is what it is. Go and get the help you need. Go and get the help that you need. And so asking questions is very important, especially if you don't know. And even for me now that I'm older, I realize that it doesn't matter what the people in your class think. They're kids. They're kids. All right? They're kids. That's it. They're children. They don't know either. And those who do, well, they're not asking questions because they know, but most students, chances are, they wish they knew the answer to and they didn't know, and they would rather struggle in silence than, succeed by asking the question. So I want to challenge you to go ahead and ask the question. And so that's the end of our time together. So just so you know, this is your muscle work. Take a screenshot, write it down somewhere, and we'll pick up here when we meet again, and we'll talk more about charts and Venn diagrams. And if we have time, we'll see. But I wanted to talk a little bit about transformations or graphing, which is a big part of exams like the BJC or BGCSE, and learning how to read those graphs as well. So it's kind of bittersweet because we're going towards our very last session together on Tuesday at 5 o'clock, okay? And at that time, I have a special announcement for you guys, something that I'm really excited about and looking forward to. So join me on Tuesday at 5 during our last session. Go ahead and like, comment, subscribe to our YouTube channel because that's where we're going to be on Tuesday. And with that being said, I have a surprise for you guys. I'm looking forward to it. And I hope that you'll be there live to catch it as well. And so with that being said, I'll see you all on Tuesday. Bye.